Okay, so we are DMA60, and today our goal is to lecture on sections 3, 4, and as much of 5 as we can get into. In section 3, we are talking about polynomials. Polynomials are made up of terms. Terms could be, let's say, 4x squared. A term could be the number 7. A term could be a single variable, or any combination of those. So these 3 individual items here are terms. There are special names for polynomials. A monomial has 1 term. So a monomial could be just 8x. A binomial is made up of 2 terms. So a binomial could be, let's say, 8x plus 9. A trinomial, as you would guess, is made up of 3 terms. So that could be, let's say, x squared minus 8x plus 9. That will be considered a trinomial, having 3 terms. So special words are monomial for 1 term, binomial for 2 terms, trinomial for 3 terms. Some other terms that we need to be familiar with are the words coefficient and degree. Coefficient is the number of each term, just the numeral. The degree is the exponent of the variable. So let me give you a polynomial. Let's say we have 8x to the third minus 4x squared plus 7x minus 9. Okay? If I were to give you this, and let's say I wanted to identify the coefficient in blue. The coefficient of this first term is a positive 8. The coefficient of this term is a negative 4. The coefficient of this term is 7. The coefficient of this term is a negative 9. If I want to identify the degree, I'm going to use yellow. The degree of this term is cubed. The degree of this term is squared. The degree of this term is an understood 1. For the last term, we do not see this, but if you recall in our lecture the other day, anything that's x to a 0 power is always equal to the number 1. So this is technically negative 9 times 1, which is still negative 9, so we don't write the x to the 0. But the degree of that last whole number by itself, the degree would be technically a 0. The degree of the polynomial would be considered the largest degree. So for this one, the degree of the polynomial would be 3. Also notice that we have all of the exponents listed in descending order. So let me write this. Exponents listed in descending order. It's very important when you are writing a polynomial that you start with the largest exponent, whether it's 5th, 4th, 3rd, 2nd, 1st, and then the 0. The next thing that we're going to be looking at is when we are working with polynomials, we are going to feel like we have reverted back to DMA40. We are going to, here we go. We are going to combine like terms. So if I were to have 8x squared minus 6x plus 4 minus 2x squared plus x plus 10. Okay, let's say I have, whoa, excuse me. Let's say I have this particular polynomial. If I need to simplify this polynomial, I'm going to combine like terms. So let me use coordinating colors. Now, 1, 2, 3, 4 of these have x's, but there's a difference. We have x squareds and we have just an x alone. So what I'm going to do is I'm only going to combine the ones that have the x squared. So 8 minus 2 is going to give us 6x squared. A negative 6x plus, now there's no number here, it's an understood 1. So negative 6 plus 1 would give me negative 5x. And then my last term that I have here is a positive 4 and a positive 10. 10 plus 4 gives me a positive 14. So what I have done is I'm combining like terms, okay? If I were to have, let's say, x squared plus 2y squared minus 6x plus 1 plus 3x squared minus 7y squared plus 2x minus 3. Okay, so if we have this, we're going to combine a 1x squared with a 3x squared. That's going to give us 4x squared. We have a 2y squared and a minus 7. 2 minus 7 is negative 5y squared. Negative 6x plus 2x is negative 4x. And last, a 1 minus 3 is going to give me a negative 2. So that's all of section 3, is learning some terminology and knowing that polynomials are written in descending order, and that when you're simplifying an expression, you're going to combine like terms, just like we had done before in DMA 40. Now, the next section, 4, is about adding and subtracting polynomials. So we are going to be adding and subtracting. Adding polynomials is what I just did, combining like terms. So if we were to have 9x squared minus x plus 10 plus negative 2x squared minus 7x minus 5, all we have to do, since it's an addition, is drop the parentheses at the front. So that's 9x squared minus x plus 10. And then here I can drop the parenthesis and all the signs are going to stay the same. So that's going to become minus 2x squared minus 7x minus 5. Those signs are not going to change. So with addition, you just simply drop parenthesis and then you combine like terms. So again, 9 minus 2 is 7x squared. Negative 1 minus 7 is negative 8x. And then 10 minus 5 is a positive 5. So for the addition, that's all we're doing, and we would be finished with that. Now let's look at the difference when we have a subtraction. Okay, let's say we have 5x minus 3 minus 2x minus 11. When it is subtraction, you're going to drop parenthesis around the first binomial. Or it could be a trinomial, whatever you have in the parenthesis. So this is just 5x minus 3. Then what we're going to do, and let me change colors here, is we are going to distribute a -1 with the second parenthesis, the one that's after the minus. So this is like an understood -1, and when you distribute that, -1 times 2x is minus 2x, -1 times -11 becomes a positive 11. So when there is a subtraction, you are just going to distribute that -1, which is going to change those signs. And then last, all we have here is to combine like terms. So what I have here is 5x minus 2x leaves me with 3x, and then -3 plus 11 is going to give me a positive 8, and then you're done. So with addition and subtraction, you're just dropping the parenthesis. With the subtraction, you do have to change the sign here, and then you're just combining like terms, okay? And now we can move on into multiplication. So with multiplying, well, hang on. If I can get that too, there we go. So with multiplying, I'm going to start with a single term or two terms, and then I'm going to look at multiplying if you have binomials. So when you're multiplying polynomials, the thing you have to pay attention to with these so at this point, when we are looking at multiple terms, I'm going to show you as with let me do a 2 times 3 term, and then I'll show you what we can do with a binomials. There's two ways we can address this problem. 5a minus 4, and then 3a squared minus 2a plus 7. Two ways that we could do it would be to take 5a and distribute it with the entire second parenthesis. Then we would take the other term, the minus 4, and still distribute it with the entire parenthesis. So we would distribute here and then the -4 here. So that's going to give us 15a cubed minus 10a squared plus 35a. On the second part, we have -12a squared plus 8a and then minus 28. So we distribute first. So distribute first. And then after we distribute, we are now going to combine like terms. When we're combining like terms, we need to remember descending order, okay? So there is only one term that has a cubed, so 15a cubed. When I look at the a squareds, there are two of those. So -10 minus 12 is -22a squared. For the a's, I have a 35 plus 8, which gives me 43a. And then last, we have minus 28. Okay? The very last thing I want to show you is how to, I'm going to use a special term here. It's called how to FOIL. F-O-I-L. First, outside, inside, and last. This is used when we have two binomials. So if I have 5x minus 1 times 2x minus 7, what I'm going to multiply first is going to be the first items here, and that's going to give me 10x squared. When I multiply the outside, that's going to be 5x times -7, which is minus 35x. When I do the inside, that's going to be the 2 here in the middle. -1 times 2x is minus 2x. And then when I multiply the last is going to be the last